Greetings, Patriots. In this lesson, we are going to look at functions or not of functions in specifically a mapping diagram or a graph. Okay, yesterday we looked at tables and ordered pairs. Today it's going to be mapping diagrams or graphs. Please take a moment to just set yourself up, look at your guided notes, and get yourself organized. Our objective is I'm going to identify a function or not a function in a mapping diagram or a graph. So what's sometimes really helpful is to actually take colored pencils at this point. But what we're going to do is we're going to use our definition of what a function is, right, in order to identify if the following maps have a function. So we need to remember that each x value has to be paired with one and only one y value. So this is where color is really important. I like to use my colored pencils. So don't forget, in a map, this is your domain. The first oval here is all your input values, all your x values. You know Miss King likes to label everything using her pink and yellow highlighter. Your range values are representing all your y values, and our focus is to only look at your x values. So in a map, if you grab a colored pencil, sometimes when you have different colors, this really helps. Remember, my input value of 4, I'm going to draw that. I'm going to try to line it up as best I can. But 4 has one arrow going to 8. That's good. That means it's only assigned one value. I'm going to grab another colored pencil. When I look at the input value of 6, I see that it is only assigned one value, and that is 2. So that right now, each of those x values has been paired up with one and only one y value. Okay, so now I'm going to grab another colored pencil. 7 only has one arrow to it, and it's pointing to 0. That's perfect. So far, so good. And finally, 9 only has one arrow coming from it, and it's pointing to 0. So remember, they can share the same common value in their range, but does every x have one arrow coming from the input value? And my answer would be yes. So therefore, I do have a function because, again, I like you to justify every element in the domain, which are your x values. Every element or every input value in the domain has one y value or is assigned, has only one y value assigned to it. So therefore, I do have a function. Okay? Now let's go ahead and look at our second mapping diagram. So once again, label your first oval as your domain values. This is your domain. And your second set of values are your range values. All of the y coordinates, okay? So once again, get yourself a set of colored pencils and let's check every x value because that's what's important. So as I take 0, I can see that 0 has one arrow pointing to it, and that means 0 has been assigned one value. I'm going to check 1. 1 has an arrow going to 2, but it also has another arrow going to 4. So this is not in compliance with my definition where that says every x value is paired with only one y value. That would be false. 1 has been paired with 2, and 1 has also been paired with 4. How do I know? Because I have 2 arrows coming from 1, and that automatically lets me know that I'm dealing with not a function. Again, though, I'm checking 6, and 6 has been assigned to 2. And that's okay because it only has one arrow coming from 6. But 1 has caused this relation to not be that special function. So it's not a function because, and I'm going to write the element of 1 in the domain, right? And I'm referring to my input value that's found in the domain has been assigned two y values or has been paired up. Any way you want to see it, has been paired. Oops, let me move that up a little bit. With 2 y values. And those values can be seen in the ordered pair right here of 4 and 2. Okay, so remember, it's not only your responsibility to tell me whether it's a function or not, it's also your responsibility to tell us how you know that. So when you are using a mapping diagram, I think that one of the best strategies to use is use color. Okay, one of the strategies I like to use is color. All right, and notice that I modeled getting different colors because it helps me focus on whether or not there's one arrow, right? Only one little arrow, one little line should be coming from your X values in order for this to be true. That's one way to look at the characteristics. Okay, now let's take a look at a graph. I have 2 more examples and that's it. If I look at the following, remember in our previous lesson, we looked at using the vertical line test, right? So if I draw a line, any line, when I'm given a graph, I should only intersect at one point. So I'm going to go ahead and draw a line right here. And when I see that, I can see that, oops, I have 2 points being intersected with my vertical line. I can do the same thing over here. And again, I have 2 ordered pairs being intersected. Well, let me look at my X value. This is 1. So that tells me that 1, actually the reason that I have an X value here, or intersection twice, is because 1 has been assigned the Y value of 2, but it's also been assigned the Y value of -2. So the fact that my X value, my input value, has been assigned more than once, this makes this not a function. So again, using your vertical line test, this would be not a function. Why? When I'm looking at a graph and you do your vertical line test, your vertical line intersects at 2 points. And you can see that at 1, and I already showed you the 2 points, 1, 2, and 1, -2. That's just one example. You could have also shown me where it intersects at -1. At -1, it intersects at 2, and at -1 at -2. So the fact that it has 2 points intersected, that's why it is not a function. Okay, let's go ahead and look at the next graph. So here, if I take my vertical line test, oh, it only intersects 1 time there. If I cross here again when I'm looking at my input values at 2, well, 2 has been assigned the value of 2. Well, that works. 1 has been assigned the value of 1. Well, that's okay. If I cross here, yep, -1 has been assigned the value of -1. So I can see that there will always be 1 point of intersection. So the line is intersecting at 1 point. When I test my vertical line, my line intersects at 1 point. And the only reason that it's intersecting at 1 point is because my X values, right, this is a function, my X values have been assigned 1 Y value. Have been assigned 1 Y value. So therefore, you have this relation is a special function. Okay, so these are the I do problems. Hopefully you took good notes and join us tomorrow as we review the we do. So Ms. King has given you a graph. You need to tell me whether or not it is a function. And she's also giving you a mapping diagram, and you need to explain whether or not it is a function. So we will talk about these in class tomorrow. Have a great day.